Let's alter this code a little bit to trace through this entire process. Down here, we've added 2 more lines. They're going to authentically change the value of my integer. We actually see that over here. The variable my integer retains its value of 5 even after an integer is changed inside the add1 function. However, after my integer is changed in our main code down here on line 12, its value is changed. So let's illustrate running this code using the same kind of blocks we showed before. When this code runs, line 2 creates the function. Lines 3 and 4 are skipped until the function is actually called. Then on line 7, we create the variable my integer and give it the value 5. So as we showed before, that's like grabbing a place in memory, which I visualize as blocks of memory just shown by squares, and we put the value 5 in it. We then create a variable name, my integer, and we point it at that block in memory. So now the variable name my integer points at a place in memory storing the value 5. That's really what we've always meant when we said that a variable has a certain value. That variable points to a place in memory with that value. Line 8 prints the current value of my integer, which as we see is currently 5. Line 10 then sends execution up into our add1 function. Add1 creates a new variable named an integer. And because my integer was passed in as the argument for the parameter an integer initially points to the same location in memory that my integer pointed to. That's how it gets that value of 5. So at the start of the add1 function call, we have an integer pointing to the same location in memory that my integer pointed to. Then on line 3, Python is told to set an integer equal to an integer plus 1. An integer plus 1 resolves to 6, and so this says to set an integer equal to the value 6. So what does Python do? It creates a new place in memory and puts the value 6 there. It then tells an integer to point at that new place in memory instead of that old place. However, that's only applying to an integer, and that's because an integer is immutable. Python can't just change the data stored in that memory location, so it has to create a new place in memory and tell an integer to point at that new location instead. So then, when an integer is printed, as expected, its value is 6. We see that right down here. We see that an integer currently points to the value 6. Now this function is done, and so execution jumps back to the main program. Line 11 runs, and it says to print the current value of my integer. But as we see, the current value of my integer is still 5. Inside that add1 function, we changed what an integer points to, not what my integer points to. Remember, the scope of an integer was until the function ended. Now that we're back in our main code, an integer doesn't even exist anymore. We're outside the function, so our computer has forgotten that variable name. But the value in memory is still there. So on line 12, we tell the code to set my integer equal to my integer plus 1. Again, this resolves to 6, and so Python knows to set my integer equal to the value 6. Fortunately, the value 6 already exists in memory. We created it for an integer. And even though Python forgot the name an integer, the value is still there. So when we run line 12, it tells my integer to point at the location of 6 instead of 5. And as a result, on line 13, when we print my integer, it has the value 6. So the fundamental takeaway for immutable data types is that for immutable data types like integers and strings, when Python is asked to change the value of an existing variable, it does not actually change the value stored in memory. In this case, it doesn't erase the 5 and replace it with a 6. Instead, it creates a new place in memory, puts the new value there, and tells the variable name to point to that instead. So it no longer points to the old value, and instead it points to the new value. This is the way Python handles immutable data types. This is pretty different across different languages. So when you start to learn a new language, pay attention to how that language handles these issues.